Absolute error is one of those concepts that you'll use in almost all of your experimentation. So let's have a look at what it is. Absolute error in a nutshell is the difference between what you measure or observe and what you expect. So it's that difference. So obviously we want that difference to be as little as possible so that your experimentation values are exactly the same, if not really close to what is expected. Now that's in a perfect world. What's probably most likely to happen in almost all of your experiments is that there will be other influences affecting your experiment that you haven't quite controlled. And of course that's part of the designing of experiments. So let's have a look at what it is. The difference between the two we can express as an equation. So if we let E be the absolute error, we find here that this is the difference between the two values, where our observed value goes first and theory goes second. Let's have a look at an example of that. Say we've got a 100-metre running track like we have the Olympics. We know that a 100-metre running track is supposed to be 100 metres long, so let's call out our theoretical value. Now let's say we got out our measuring device and we actually measured, we'll call out our observed value O, 99 metres. Okay? You're probably thinking that's not 100 metres. You're right, in this case it is very obvious. But other experiments it may not be so obvious as to how far off the mark you are. Let's have a look at this. So if we put E equals O minus T and then substitute in our values, O is 99 metres, we take away theory, which is 100 metres, we actually get an answer of minus 1 metre. And here's our first point of the video. We'll find that E is actually in the exact same units as the measurement itself. So here's the measurement here, and here's E, and you'll notice that it's in the same units. Let's write that now. So that's a really important concept there, is that absolute error is in the exact same units as the measurement itself. Now what is absolute error a measurement of? Well, it's actually a measurement of accuracy and validity. How close you are to what's expected, that's accuracy. And therefore we can comment on whether or not our experiment is valid. Okay, so that's a really important concept as well as the same units, to understand that absolute error is a measure of validity and of accuracy. So let's go back to this example. Let's actually ask ourselves, is this acceptable? Now you're probably thinking, it sounds obviously it's not. It wouldn't be fair to have a 99-metre track when it should be 100. But what actually is accepted? Because there are differences allowed. It's called tolerance in a 100-metre running track. And I did a bit of research, and it so happens that they're allowed to have what's called plus or minus 0.04 metres. Okay, so that's 4 centimetres. That's what their tolerance is on international standards on 100-metre racetracks. So that means, if we actually do the maths on this, that a racetrack could be 99.96 metres long. That's if we take away 4 centimetres. Or it could be 100.04 metres long, somewhere in that range. Clearly, our value of 99 metres does not fit in with that. Okay, so this would be an unacceptable racetrack by international standards, but it might be good enough for things like maybe junior school or what have you. So that is absolute error, and what we're looking at is how valid and accurate our data is. What does that mean? It means, are we actually getting experimentally, that's our O, close to what we're getting in theory?